What is going on, guys? This is Daniel from Engineer's Note. In this video, we're going to learn three things. First, what on earth are elementary matrices? Secondly, I will tell you how to form elementary matrices from certain row operations. And thirdly, I'm going to teach you how to get an inverse of an elementary matrix. Okay, so let's begin. So this example is also from my last video explaining Gaussian elimination. So if you haven't watched those videos, please check them out. And so I will assume you guys already knew about Gaussian elimination and its two processes, like for elimination and backward substitution. So let's begin. So in for elimination step, what do you do? Like, so you subtract the first row, multiply by 2 from the second row. So it's like raw operation, right? So you do raw operations to go through the steps in Gaussian elimination. So you do raw operations. So what I want to tell you is there is a matrix that does the same thing as the processes in Gaussian elimination. So I will call this step is first step, this one is second step, and this is the third step. So I want to find out a matrix that does the same thing as the first process in Gaussian elimination. So what does the first process do? So what it does is subtracting the first row multiplied by 2 from the second row, right? So I want to find out what E1 is. So let me just write here E1. So what does E1 to the first row? So first row remains the same, right? First row for the first row stays the same. So that means E1 wants one of the first row, none of the second row, and also none of the third row, right? And for the second row, what does E1 to the second row? So 4 minus 6, 0 becomes 1 minus 8 minus 2, right? So what E1 does is subtracting the first row multiplied by 2 from the second row, right? That means they want minus 2 of row 1 and 1 of the second row. That is exactly subtracting the first row multiplied by 2 from the second row, right? And also none of row 3. As for the third row, so what does E1 to the third row? It does nothing. It stays the same, right? So E1 says stay the same to the third row. So for the third row, we want none of the first row, none of the second row, and 1 of the third row, right? So we can formulate E1 from these mathematical expressions. So let's make E1. All right, E1 is obviously 1 0 0 minus 2 1 0 0 0 1. 1 0 0 minus 2 1 0 0 0 1. That's it. So here is what I want to put an emphasis on. So if you multiply this elementary matrix, you should multiply E1 in front of a matrix, not behind the matrix. So for example, you have to multiply E1 in front of some matrix, okay? That way it does the raw operation. If you multiply E1 behind the matrix, it doesn't do raw operation. Actually, it does the column operation, right? So make sure you multiply elementary matrix in front of a matrix. Okay, so by multiplying E1, actually this matrix becomes E1A. And to maintain the equality, you should multiply E1 to B as well. Here's B, and here is E1B. So in the same way, this becomes E2 E1A, E2 E1B, and it becomes E3 E2 E1A, and this becomes E3 E2 E1B. So E3 E2 E1A becomes U, and this becomes C. This is called an upper triangle matrix because it looks like an upper triangular. So AX equals B becomes UX equals C. Okay, so we've done the first thing, elementary matrices, and how to form elementary matrices from certain row operations. And lastly, how do you get an inverse of an elementary matrix? So let's think about it. So in this process, AX equal B becomes E1A X equals E1B, right? So what would you do to go backward? So you would multiply E1 inverse, right? So what is E1 inverse? Let's just think about it for a second. So what E1 does is subtracting the first row multiplied by 2 from the second row, right? So if you want to go forward, you subtract the first row multiplied by 2 from the second row. So if you want to go backwards, you can just multiply the first row, you can just add the first row multiplied by 2 to the second row, and it becomes this. So what would E1 inverse look like? It's simple as hell, right? 1 0 0 2 1 0 1 1 1 0 0 1. So you just put minus sign here because you want to add the first row multiplied by 2 to the second row to go backwards. So here is plus 2. That's it. This is E1 my inverse. So here's how you can get an inverse of an elementary matrix. Alright, that's it for today. Thanks for watching. If you like this video, please hit the like button and subscribe to my channel. I hope to see you in the next video.